Hey class, it's Mr. Z doing another skill video. If you've mastered long division, you're ready to take the next step and go up the next flight of stairs in this unit, I welcome you. If you haven't, go back and review. Let's go ahead and dive on in. Alright, so what we're doing here is determining each quotient using synthetic division. We're going to write the dividend as the product of the divisor and the quotient plus the remainder. Really, it's about just kind of remembering that the remainder is going to be this extra thing. So when you're doing synthetic division, you want to look at everything in the term, the dividend, but you're going to want to zoom in on the coefficients. I see a positive 8, a negative 3, a negative 24. Well, what is the coefficient of x to the fourth? If you know that it's a positive 1, you're a step ahead of the game. Now, the only other thing before we go is that with experience, you'll know why, but you always have to check if it's in polynomial form. And currently, it isn't. What I mean by that is a polynomial will go x to the third, x squared, x, and then a number. You can think of it as descending order. It goes 3, 2. There's an invisible exponent of a 1. And if you want to think about this instead of just a number, you could think of it as x to the 0 power, because x to the 0 power is equal to 1. If I do 1 times x to the 0 power, that's actually saying 1 times 1. So it actually doesn't change it by including it. This is all just extra. But what I'm trying to show you is that you need to have it in this order. The statement I wrote above, I'm going to go ahead and alter it a little bit. I'm going to write x to the fourth plus x squared plus 3. In order for it to be a polynomial, I'm going to have to include the missing terms. There is a 1 in front of it, but notice how there's no 3. Well, there is 0, x to the 3. Continuing, how many x squares are there? 1. Well, the next one should just be x. How many are there? 0 plus 3. In order for synthetic division to work, you need to have it be in polynomial form, and then you divide using synthetic. So, the problem that we're looking at, we're going to first evaluate what is the linear factor for my 0. So, x minus 3. Hopefully you can look at it right now and just know what it is. X minus 3 is equal to 0. Oh, by adding 3 to both sides, I identify that at 3. So, let's go ahead and use this 3. We're going to put it over here, and we're going to write out our coefficients. 1, 8, negative 3, negative 24, and I need to include this extra 0 because there is no number here. This statement is the same as saying 1x to the fourth plus 8x to the third minus 3x squared minus 24x plus, well, there's nothing. Well, I can represent nothing with a symbol. This is minor, but in order for this to work, and in order for you to not use the long division, this is how it's going to happen. You need to fulfill these requirements. So, now I'm going to use an algorithm that at first is going to be a little odd, but I'm going to go ahead and show you. So, I'm going to bring down this first number, and it's going to be 1. Now, what I'm going to do is I'm going to currently do my first step. I'm going to take the number I brought down, 1, and I'm going to multiply it by 3. In order to be a little better, I'm not going to use an x. I'm going to use a parentheses. We're in math 3. Okay? 1 times 3 is going to be equal to 3. I'm going to put that here. And what I'm going to do is add 8 and 3. And I'm going to get 11. I'm going to repeat. What I'm going to do next is I'm going to go ahead and take that 11. And I'm going to multiply by the 3. And I'm going to go ahead and get 33. So I'm going to put that here. I'm going to add these two together. I'm going to get 30. What I'm going to do now is I'm going to go ahead and take that 30 and multiply by that 3. That is going to be 3 times 3. It's 9 with a 0. Get the trend, put it there. I'm going to take the sum. Now, since these are different integers, I'm going to actually subtract. I'm going to first do 90 minus 20. 90 minus 20 is 7d. Take away 4 more, and you get 66. I'm going to now do this one more time. And I'm going to go ahead and take 66. And I'm going to multiply it by 3. And I'm going to get, well, without a calculator, I'm going to actually treat it as 60 plus 6. And I'm going to go ahead and distribute the 3 in. 3 times 6 is 18 with a 0. 6 times 3 is 18. You see how I was able to calculate 196? Okay. So 196 plus 0 is going to be 196. All right. We've done it. I know it doesn't look like we did anything. We're going to go ahead and translate our synthetic division and get the answer we require. So, looking at it, we are taking something, just if I look at the first term, I'm taking something x to the 4th, and I'm going to be dividing it by x to the 1st. I'm only looking at that first term. My first term, my divisor term. This is going to be a degree 3, right? The answer, whatever it is going to be degree 3 because I'm dividing by 1. So if I'm dividing by 1, this 1 isn't going to be connected to x to the 4th. This 1 is going to be 1x to the 3rd. Do you see how I took x to the 4th and I divided it by an x, reducing it to the 3rd? Now, what type of 11 is it? Well, it's a positive 11, and it is going to be the same. And I continue. So now I'm at the polynomial form where I am past the number. This is this extra bit that needed to be watched for. 196 is the remainder. And I can't just do plus the remainder of 196. I actually have to represent this algebraically. In order to understand what the remainder is, look at an easier problem. I am going to go ahead and divide 2 into 5. 2 goes into 5 2 times, and I have 1. I go around the world, and what is it? Well, 1 or 2 and 1/2. Notice how the divisor is the denominator. To help see, it'll be the same color. So instead of writing remainder 196, I'm going to write, it is going to be 196 all over the divisor, which is x minus 3. Now, it wanted us to write it as a product right here. So this is what I got. And then I'm going to write times x minus 3. Right? This is what we divided. We got our quotient times our dividend. And this is going to equal the original. Notice degree 3 times degree 1 is going to be a fourth degree. All right, the second synthetic division is going to be very similar. This time we're going to go a little quicker. Synthetic division. First thing to do is convert it into polynomial form. So I ask myself, is it in polynomial form? I see that 2x to the third is how I'm starting it. 21x squared plus 22x minus 45. It is good to go. It is in polynomial form. This is the first thing I do is I'm using a sight check. Now, I need to figure out what is the linear factor that makes it 0. So I'm going to look at my divisor, 2x plus 5, and ask myself, what makes it 0? If I need to, I can use algebra to determine that 2x is going to be equal to negative 5, meaning x is equal to negative 5 halves, or negative 2.5. Okay, I'm going to keep it in fraction form. It's actually make things easier, but this is kind of how I set up. I have to figure out my linear factor, and then I have to make sure it's in polynomial form. Now, I'm going to go ahead and set it up. I'm going to use negative 5 over 2, and I'm going to go ahead and write the coefficients. 2, 21, 22, and negative 45. Okay, let's get this started. I bring down my first number. So I'm going to go ahead and bring 2. And what I need to do is I'm going to take 2 and I need to multiply it by negative 5 over 2. Processing fractions, just remember the denominator is 1. And I see that 2 over 2 is going to be negative 5 times 2. And it's going to be 1 times 2. I know that 2 divided by 2 is going to cancel each other out. So I can see that it's going to be negative 5 instantly. I add them together, and I get 16. Let's set it up again. Now, let me use a different color. So now, number 2, I'm going to take 16, and I'm going to multiply it by negative 5 over 2 again. Now, you can think of it as a denominator of 1. That always helps. But I'm going to actually think about it this way. I'm going to think of it as 16 divided by 2, and then I'm going to multiply it by negative 5. The reason being is I see 16 as an even number, and 16, you can take half of it relatively quickly and pain-free. Well, what is half of 16? Half of 16 is going to be 8, and then I'm going to multiply that guy by negative 5, giving me negative 40. Okay, let's continue. Negative 40. I'm going to combine these two, and they're different integers, so I'm going to subtract. 40 minus 20 is 20. 20 minus 2 is going to be an 18, and it's negative. I'm going to take my negative 18 and use a similar process to figure it out because I know negative 18 is even. So instead, I'm going to think of it as negative 18 divided by 2 and then multiplying by negative 5. And then this is going to lead me to get negative 9 times negative 5, which is going to be 45. 45 and 45 make 0. Awesome. Let's go ahead and interpret what our thing is. Look at your leading coefficients. I had x to the third, and I'm dividing it by 2x. X to the third divided by x is going to be x squared. So I hope you can understand why 2 is going to be 2x squared after the division. 16x negative 18. And this remainder would be 0 over 2x plus 5 because it's the remainder. The remainder is always a fraction over the divisor. But the cool part about that is with the numerator 0, I can just leave it as 2x squared plus 16x minus 18. Right? Now, I actually see something, and I'm going to go ahead and immediately GCF factor. Why? I'm going to factor by 2, and the reason being is they're all even. So this is actually going to be 2 times x squared plus 8x minus 18. I can actually keep going and factoring this. Let's go ahead and set up a square. I take my leading term, x squared, negative 18, and my goal right now is to get these two squares to be equal to the 8, positive 8. I don't really care about the 2 in front right now. So I'm thinking about the factors of 18, and I'm going to try to figure out how I can get to 8x. And I'm going to go ahead and here take a minute so you can try. Negative 6 and 3, x and x. Multiply it out, 3x minus 6x. Ask yourself, does negative 6x and 3x make 8x? No. Darn. Let's try something else. 6 and 3. I'm going to go ahead and try 9 and 2. Negative 9. This is going to make negative 9x. This is going to make 2x, and that's going to make 7x. Dang, that didn't work. Well, the only factor left of 18 that I haven't really tried is 18 and 1, and I know this is definitely not going to work. So what this means is this is fine. This is unfactorable. You're going to have to use imaginary numbers. So we can conclude by saying, well, what did we do? Looking at my original problem, I had 2x to the third plus 21x squared plus 22x minus 45, and I divided it by 2x plus 5. What I got from my synthetic division is that the 2x squared plus 16 minus 18, and after factoring it, I became 2 times x squared plus 8x minus 18. I'm going to multiply it by my divisor, and then this is going to equal my starting answer. Notice, I'm going to use some words to help describe this and put this into terms. It's always going to be the same order. Once you get it down, you'll be fine. This guy right here is called the dividend. This guy right here is the divisor. Notice how here the dividend is on this part. This is the end. This is everything put together. This is the divisor. And here is my quotient, the answer to the division problem. Knowing this is going to level your factoring up. It is going to enable you to factor complex functions. Whew. Rest easy, guys. Have fun.